Are there any questions? Going lopsided. What did you two do to drive everyone over here? This is different. All right, so I've got a bunch of stuff graded that I haven't reported yet, unfortunately. So I'm hoping that we'll have school on Thursday and I can actually get it back to you. I noticed for a number of you, a large gap in understanding the difference between acceleration and velocity. And this comes down to velocity. Velocity is very much related to speed, but it's not complete. Velocity is a vector, so therefore there has to be a direction, and in terms of plus minus 0, the direction determines the sign. If velocity is positive, that means you're moving in, the object's moving in a positive direction. If it's negative, you're moving in a negative direction. It doesn't care about where you are or what you've done. It just cares about what's happening at that moment. Acceleration the vector acceleration, as opposed to the scalar, which doesn't have the vector symbol over it, is the rate at which velocity changes. And that's a key point there, is that if velocity does not change, acceleration is 0. But I can be going really fast and have 0 acceleration. I can be very slow and have high acceleration. It all depends upon, acceleration depends upon how velocity changes. And velocity changes. If you're in a car, what are the 3 things that you can do to accelerate from a physics point of view?
Hit the gas pedal.
Okay. So hit gas pedal, or which would cause you presumably to speed up,
The steering wheel.
which would cause
Changing direction.
and the third thing,
The brake pedal.
so if any one of these things happens, there is acceleration, non-zero acceleration. The other thing, before I hand out this exercise, what? Dude, not what it was. Mathematically, I know that velocity is the change in position over the change in time. So velocity requires that there is a change in position. So you are no longer at the same location. If you are at the same location, then, well, if it's one moment to the next, then your velocity is 0. If it's one moment to a day later, because I was standing here last Tuesday, somewhere around here. So my average velocity is about 0 because I ended up back where I started. But if I have a position time graph, and I'm looking at something like that, well, if I take 2 points on that line, and I look at, I have some change in position here, and some change in time there. Well, if I do change in position over change in time, that's velocity, and that's also the slope. So the slope of position versus time equals velocity. And it also is that the slope of displacement versus time is also velocity. Because the only difference between a position graph and a displacement graph is shifting up and down. Displacement graph is going to start at the origin, position graph's not necessarily going to start at the origin. Likewise, acceleration deals with how the velocity changes. And again, going through the same idea that if I have a velocity versus time graph, and I take 2 points, I'll have some change in velocity there, and some change in time there. And so change in velocity over change in time not only is acceleration, but it's also the slope. So the slope of acceleration versus time, mistake. The slope of velocity versus time is acceleration. Questions up to here? So what I'm going to do is I'm going to hand out an exercise here. Should be enough for everybody.
Oh, it's
I'm given the set.
okay. Set.
Read my mind.
Excellent.
What I want you to do, this is similar to that lab exercise, but I've given you a bunch of position versus time graphs, and I want you to work with somebody. This is not meant to be a solo exercise. Have a good discussion, trying to figure out what these things actually mean. If you need to stick numbers on there, or you need a meter stick or a tape measure or anything like that, I'll be glad to bring it to you. So, but I want you to sort of figure out what does the velocity time and the acceleration time graph look like. And then, given the velocity time graphs, figure out what position time graph looks like and the acceleration time graph. And then, if those were acceleration graphs, what would velocity and what would time look and position look like? Just not planning to spend the entire class on this, but let's say given a good chunk of time here, and just the point is to understand this is not for a grade. This is to ask questions. I am going to disappear at some point because, well, sometimes the body wants to do what the body wants to do. I would say rejoice. It's not a lab, but as always, rejoice. But work with somebody. Feel free to move to a different space if you need to. Shift tables around if you you have to. Talk, explore, communicate, learn. And get in Jennifer's way.